Welcome dear students. So today we are going to start a new exercise from chapter number 12, and the exercise number is exercise 12b. Okay, so in this particular exercise you will solve the problems on equal intercept theorem. Now in the first video itself we are introduced with this particular theorem called equal intercept theorem. So basically this picture that you can see right now has been taken from that particular video only. Okay, so which says if a transversal makes equal intercept on 3 or more parallel lines, then any other line cutting them will also make equal intercept. That's the statement. Now here I am taking 3 parallel lines L1, L2, L3, okay, and there is a transversal which is making equal intercept, that is AB is equals to BC. Okay. Now if you take any other transversal and cut the very same 3 parallel lines, that is this one, then the transverse intercepts made here are xy and yz. As per equal intercept theorem, this xy and yz, they must be equal. Okay, so this is all about your intercept theorem. Now let's take few problems from exercise 12b in order to understand the usage of this particular theorem. So we have the first question on the screen which says use the following figure, that is this figure, to find these particular things. Okay, so let's take one thing at a time. Now according to the equal intercept theorem, see here very carefully. See, according to equal intercept theorem, since it is given that CD is equals to DE, isn't it? So basically you see these 3 arrows means these 3 lines are parallel. So isn't this CE acting like the transversal? Yes, and also it is given that CD is equals to DE. Okay, so that means this also acts like your transversal, and here this becomes CB is equals to BA using equal intercept theorem, and this line also acts like the transversal, and in this case using intercept theorem you have GF must be equals to FE. Okay, now so therefore I told you AB must be equals to BC and EF must be equals to GF. Okay, now number 1, so you need to find BC if AB is given to you. Okay, so you need to find BC if AB is given to you. So AB is given to be 7.2, isn't it? So that's why if AB is 7.2, then the value of BC will also be equals to 7.2 centimeter. That means we got our first answer. Let's see what is GE. So GE is this one, isn't it? Now here GE, can I write GE? Okay, can I write GE as GF plus EF? Yes, definitely, yes. Okay, now see here carefully. You know EF and GF, they are equal, isn't it? So in place of GF, if you write EF, you get EF plus EF, which is 2 times EF. Okay, now here what you need to find is if EF or FE is 4 centimeter, you need to find what is GE, right? So GE is going to be 2 into EF is 4, right? So 2 into 4 is 8 centimeter. Okay, so I got my second answer. So let's find what is AE. Okay, if BD is given, so BD is given. So BD is given, you need to find what is AE. Okay, now if you observe here, if you observe this triangle, okay, so since BDF are midpoints, okay, so BDF, they are midpoints, isn't it? Right? So B is the midpoint of AC, D is the midpoint of CE, and F is the midpoint of GE. And also these are parallel, that is AE is parallel to BF and BF is parallel to CG. Can I make use of something called midpoint theorem here? Yes. So midpoint theorem says that in this triangle, okay, so B and D, So B and D being the midpoints, so this line will be just half of AE, or in other words I can say that AE is double of BD. Okay, and in this triangle DF, okay, so DF is going to be half of CG, or in other words CG is double of DF. Okay, so that's what is written here. Okay, so what you need to calculate is, you need to calculate AE, isn't it? So BD is given, so calculate AE. So we have AE equals to BD, as you can see. So BD is given to 4, right? 4.1, I'm sorry, this is not 4, this is 4.1. So 2 into 4.1 is nothing but 8.2 centimeter. That means the value of AE will be 8.2 centimeter. Okay. So we have DF, as you know, DF is just half of CG. So CG is given to be 11. So put CG equals to 11, you get half of 11 is 5.5 centimeter. So we got our all answers here. Pause the video and note down your solution. Alright, so let's take question number 3. See, in this particular exercise, I'll be skipping most of the sums because most of the sums are dependent on the chapter on triangles, which we have not yet done. Okay, so that's why we'll just see the problems where we'll make use of just the theorem, that is equal intercept theorem. Now question says the side AC of triangle ABC is produced to E. So without making any confusion, let me show you the respective diagram. So diagram says that the side AB, okay, so there's a triangle ABC and the side AC is produced to point E. Okay, so AC is this one. So you have produced this to E. Okay, so that CE, this CE is half of AC. Okay, so CE is just half of AC. Now D is the midpoint of BC. So D is the midpoint of BC, and ED, okay, see here carefully. So ED produced, okay, so when you produce this ED meets AB at point F. Okay, now lines through D and C are drawn parallel to AB. Okay, parallel to AB. So from D you have to draw a line parallel to AB. Okay, which meets AC at point P. Okay, and from C also you have to draw a line parallel to AB, and it meets EF. Okay, so that is this line at point R. Now you need to prove that 3 times DF is equals to EF and 4 times CR is equals to AB. This question is very simple. Let's say, see, only thing is you have to draw the diagram properly. Okay, so after the diagram is drawn, your work is very simple. Let's see the work. Okay, so here you know D is the midpoint of BC. That's what is given, isn't it? And DP is parallel to AB, isn't it? Yes, that's what is given. So we say, see here carefully, D is the midpoint of BC. Okay, and DP is parallel to AB. So can you say that DP is going to be half of AB? Yes, using midpoint theorem. So DP or PD is half of AB using midpoint theorem. Now again from triangle AEF. So let's see where is triangle AEF. So AEF is this particular triangle. Okay, now we have AF, right? So AF is this one. So AF is parallel to PD and this is parallel to CR. Okay, so that's why AP, okay, see here carefully. So AP is gonna be just 1/3 part of AE. Okay, fine. Now therefore we see, okay, so what is AP actually? See here carefully. So we have AP is this one, isn't it? So if AP is this much, then if AP is this much, right, then we have DF. Okay, so where is DF? Let's see this one. Okay, so DF is also going to be since you know that P is the midpoint, so D is also the midpoint. So that is why using midpoint theorem, so we can say that instead of AP just write DF, okay, and instead of AE, that is this thing, you can write EF, okay. So take this 3 out here, so you get 3 times DF is equals to 1 times EF, which is EF, okay. So that is what we need to show at first. So let us take number 2. Okay, now from triangle PED, so let us see where is PED. PED is this particular triangle, okay. Now if you look at this particular triangle, we have PD is parallel to CR. So in other words, can I say that also C and R are the midpoints. So can I say that CR is just half of PD? Yes, using midpoint theorem, okay. So that is why, now see here carefully, we already know that PD is half of AB, right. So if I multiply both sides by half, what do you get? You get half time PD, half into half is 1 by 4. Now what is half PD? Half PD is CR. So in place of this, let me write CR. So CR is equals to 1 by 4 AB. So bring this 4 out here, so you get 4 CR equals to AB, and that is what we need to prove here. So you may pause the video and note down your solution. Okay, so let us take one more question from this particular exercise, and this is going to be my last problem from this particular exercise, okay. So question says, okay, so first let me show the diagram here. So in triangle ABC, D and E are the points on AB such that D and E are the points on AB such that AD is equals to DE is equals to EB. Through D and E, lines are drawn parallel to BC. So lines are drawn parallel to BC, which meets side AC at F and G respectively. Now through F and G, lines are drawn parallel to AB, that is this line and this line, which meets the sides BC at point M and N respectively. Now prove that BM, okay, so BM is equals to MN is equals to NC. That is what we need to prove here. So without further delay, let us see. So for triangle AEG, so AEG is this triangle, okay. So can I say that since D is the midpoint and DF is parallel to EG is parallel to BC, can I say that F is also the midpoint? Yes, okay. So F is also midpoint of AG, okay. Now see here carefully, D is the midpoint and DF is parallel to EG, okay. So automatically F becomes the midpoint of AG using midpoint theorem, okay. So that is why I am writing AF is equals to GF, okay. Let me call this to be equation number 1. Now again DF is parallel to EG, right. So DF is parallel to EG, which is parallel to BC, right. Now DE is equals to BE, DE is equals to BE, that is what is given, isn't it? DE is given to be equals to BE. So that is why GF must be equals to GC again, okay. So we have, let me call this to be equation number 2. So we have from 1 and 2, if I combine 1 and 2, can I say that AF is equals to GF and this GF is equals to GC? Yes. So that is what we get from equation 1 and 2, okay. Now see here carefully, since similarly, okay, in the same way whatever we have done here, GN is parallel to FM, okay. So GN is parallel to FM and it is parallel to AB. So therefore in the same way we can show that, just now what we showed that AF is equals to FG is equals to GC. So when you consider these two lines being parallel to this, in the same way you can show that BM is equals to MN and this is equals to NC, okay. So with this we close for the day. Thank you very much.